So this one is pop quiz 13 related to mass spectrometer and the ionization energy. As you can see, the first ionization energy of the period two elements are shown here in lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, and neon. Give an equation that represent the first ionization energy of the lithium, including a state symbol. So ionization energy, first ionization energy means energy needed to remove electron from a neutral gaseous atom. So we will have a lithium, which is a neutral and it is gaseous. And we supply energy so that we can remove the first electron out. So we call that as the first ionization energy. Because that's the energy needed to remove electron from a neutral gas. The first ionization is energy needed to remove electron from a neutral gaseous atom. And the charge on electron, don't forget to write the charge on electron. So that should be negative. Explain why there is a journal increase in first ionization energy across the period. Look, there are dips. You can see boron and beryllium and boron and nitrogen and oxygen does not follow that. But what is the journal trend? Generally, you will see that the ionization energy is increasing as you are moving across the period. So how you explain this journal trend, why the ionization energy is increasing as we move across the period? Because when we move across the period, what you will see the nuclear charge increases. The same shells, but more nuclear charge. So because like lithium is there 3 proton, beryllium is there 4, boron 5, carbon 6, nitrogen 7, oxygen 8, fluorine 9, and neon 10. So generally when we move across, the number of the proton increase. As a number of the proton increase or a nuclear charge increase, and they have the same shells. So how you write this answer, you will mention. So the elements in the same period have same number of electron shells. Then what will happen as we move across the period? So as we move across the period, what will happen? The nuclear charge or the number of the proton increase. So as the nuclear charge or the number of proton increases, there will be a stronger attraction towards the valence shell electron. And when there is a stronger attraction towards the valence shell electron, what will happen? The ionization energy will increase. So this is always the structured answer. Like whenever a question is there that why the ionization energy increases as we move across the period, then you should always refer these points. Then the next one, as not all of them are following a trend. Like example, first ionization of oxygen is lower than nitrogen, even though oxygen should be higher according to what we write a reason. But when we check the graph, oxygen is lower. What is the reason for that? When we write the electronic configuration for nitrogen, it is 1s2, 2s2, 2p3. When I show electron in a box model, 1s2, 2s2, and 2p3. So first, like pair, when in a p orbital, they will occupy singly. But in case of oxygen, which is 8, when we write the electronic configuration of oxygen, 1s2, 2s2, 2p4. So when we represent the electron in a box model, so here it is having pair of electrons, and then first they will occupy singly, and then there is one pair. As a result, what will happen? This pair of electron will have more repulsion than electrons occupying the orbital singly. So as they have more repulsion, it will become easy to remove the electron So first, when we mention like how to summarize this, how to explain this idea, we'll mention like electrons for both cases. We are removing the electron from 2p orbital. Even in nitrogen, even in oxygen, we are removing the electron in 2p orbital. And in 2p orbital of oxygen, there is one paired electron and they have more repulsion as compared to that in nitrogen, in which all of them are unpaired. Unpaired electrons, when they are occupying it singly, they have repulsion but less repulsion, but in this case, they have more repulsion. So if they have more repulsion, it will become much more easy to remove electron. Like if I supply small amount of energy, I can easily remove these electron as compared to when they occupy singly. So the common, like the structure of the answer, how the structure should be for these type of question in which we are comparing group 5 with group 6 elements, the ionization energy. So both cases, electrons are removed from same subshell, which is 2p. So they have the same shielding effect. If you remove the electron from same subshell, they have the same shielding effect. But what actually happened? Oxygen contain pair of electron in 2p, where nitrogen has unpaired electrons and the paired electrons have more repulsion. So it will be easy to, so small amount of energy can remove the electron. A small amount of energy can remove electron from oxygen compared to nitrogen. So that's how you should always write this structure whenever you're comparing group 5 element, like same thing. Sometime the same question, they can mention phosphorus and sulfur. Instead of oxygen and nitrogen, it can be. So same answer will be there. The only thing which we will change in that case, will change this, because in oxygen and nitrogen, it is in 2p, but phosphorus and sulfur, that will be 3p. But the same reason. In part B, all the successive ionization energy of a nitrogen are shown. Like when we are removing electron from nitrogen, explain the trend in successive ionization. So look, 1402, 2800, 4500, then 7400, 9000, then 53,000. So look, this is called comparative. Like it is approximately double, approximately double, approximately double, not approximately double, but it is the same range. But when you see this is a big jump, when there's a big jump in the value, what it shows the shell has changed. So if the shell has changed, so it means how many electrons are there in the last shell of a nitrogen. Nitrogen is having 5 electrons in the last shell, because these are comparable. But then there's a very big jump from 9,445 to 53,267. So whenever there's a big jump in the ionization energy, this gives an idea that the shell has changed. So the point, like generally what will happen, as you can see, the ionization energy is increasing. Why the ionization energy generally increase? Because when we remove the first electron, it will have more proton than electron. When we remove the second electron, like there will be more positive charge as compared to negative charge. That's why generally ionization energy increases. So the ionization and successive ionization energy for the element increase. And why it increase? Because it when we remove the electron, there will be more protons than electrons. So they will have a stronger attraction. That is the one thing. Then why there's a big jump between the fifth and the sixth? Why there's a greater difference? Because the shell change, so the electrons, the sixth electron will be closer to the nucleus, because when we always remove the first electron from the last shell. So when we draw the structure of a nitrogen, like nitrogen is there, first shell it has 2 electrons, the second shell it has 5 electrons according to the configuration. So we remove, when we remove, like we remove this first electron, then second electron, third, fourth, and fifth till here. But when the sixth electron is removed, it is removed from inner shell. So it will have a much more stronger attraction. The fifth and the sixth, there's a greater difference because the shell changes. The sixth electron is removed from an inner shell, which is closer to the nucleus. Which is closer to the nucleus. So when it is closer to the nucleus, it will have a stronger attraction. That's why it will have a much greater, greater amount of energy is needed. That's why it has a very high ionization energy. So when you explain the successive ionization energies, this is how your structure of the answer should look like. So this was a pop quiz 13, which was related to mass spectrometer and the ionization energy.